In this video, we're going to use the trig ratios to find missing angles. And you'll notice in the first question here that we're after angle theta, and we've been given three sides. And the 3, 4, 5 structure, remember that's a Pythagorean triad, so this is fairly common. But to find the angle theta, we need to use only two of the three sides. And we know that this side is the opposite, and this side's the adjacent, and this side's the hypotenuse. I'm going to use tan ratio, no particular reason, and we know that tan theta is equal to opposite over adjacent. So that means that tan theta, this is the substituting stage, is equal to 3 over 4. So that means that tan theta is equal to 0.75. Now, what's different about this is we're kind of working in reverse. We're being told what the tan of the angle is, and we can work to the angle. Where in all the other questions that we've done to date, we know the angle, and then we find the tan or the sine or the cos to help find a missing side. So this is the reverse process. We're going from the tan of the angle to the angle. So far we've gone from an angle to either the sine, cos or tan. So the way that we show that we need to do the opposite process is we put our tan on the other side and we put to a -1, which is an exponent thing, but it doesn't mean an exponent. It means we're going to do the opposite process. So we're not going to find the tan of an angle, we're going to find an angle where the tan of it is 0.75. So the way that we write that is tan to the -1, the opposite process. So we need to find, using the tan ratio, an angle that the tan is 0.75. So using the tan to the -1 button on our calculator, and you need to use a second function or whatever key before that, that will come out at 36.87, and there's probably a few more decimal places, degrees. Now, that answer's usually good enough, but there may be occasions that you need to give that in smaller units than degrees, which are minutes and seconds. So to do that, you need to then do a second function and the key that gives you degrees, minutes and seconds, which on a sharp is a DMS. So if you do that, and remember I'm saying that's optional, is 36 degrees, 52 minutes and 12 seconds, and we may have rounded to get that 12 seconds. Okay, moving on to another question. This one's a problem-solving question. A plane flies 200 kilometres north, picks up passengers and flies 300 kilometres east. So if they start from here, they fly north 200 kilometres, and then they fly east 300 kilometres. How far from the starting point is the plane? So in other words, what's this distance here? And you can see we've got a right angled triangle here because the angle between north and east is 90 degrees. This is a Pythagoras question. We don't need to bother with trigonometry for this. So we know that Pythagoras' theorem is h squared equals a squared plus b squared. So d squared is equal to 200 squared plus 300 squared. So d squared is equal to, this is a really big number, 130,000. So d is equal to the square root of that, I'm abbreviating this a bit, which is 360.6 kilometres. And because d is basically the hypotenuse of the triangle, that kind of makes sense. Now, the second part of the question is, what bearing will the pilot fly on to go back to the starting point? So they're here at the moment and they want to fly back to where they started from. So we're going to need this angle here, and we need to think of a little compass sort of bearing thing here, and we'll need this angle theta. And the ratio that we'll need to use this time will be tan, because this side here is the opposite and this side here is the adjacent. So tan theta is equal to opposite over adjacent. We know that tan theta is equal to 200 over 300. So tan theta is equal to 0.6666 recurring. Okay, now let's just rearrange this first. I was going to talk about the use of calculator. So that means that theta is tan to the minus 1 of 0.6666, and I'll do the recurring. When you do this on your calculator, make sure that you fill up the display of your calculator with sixes. Don't just put in 3 or 4, it's not enough. Okay, and then once you do that, you get an angle of 33.69 degrees, which is also 33 degrees, 41 minutes and 24 seconds. So to answer the question, what bearing will the person fly? Well, if you think of it as I'm going to need to redraw this, it's just too untidy. So if we draw this, the person's coming back here to the original place, and this is our 33.69 degrees. I won't worry about the minutes, seconds answer. So this as a true bearing is the angle around to here, so as a true bearing it's going to be 270 degrees, take away 33.69 degrees, which is equal to 236.31 degrees true. Or as a compass bearing, it's going to be south and 56.31 degrees west. Moving on to the last question. And we've had a little slippage here. We've been asked to complete this triangle. That means you need to find all the missing sides and all the missing angles. So you can see that this side here, which I'll call A, you can find that. We'll need to do some other labelling too, actually. So if we're going to call that missing side A, that's opposite angle A. And so this would be B, opposite little b, and this would be side C, opposite angle C, which is 90 degrees. Okay, so using Pythagoras, which is h squared equals a squared plus b squared, 72.3 squared is equal to a squared plus 49.1 squared. So that means that a squared is equal to, and I'd need to just shorten this a lot, so we need to actually work out the squares, do some rearranging, take the square root, but a squared is equal to 2816.48, which makes a equal to the square root of that, which is 53.07. So we've got all the sides now, and that side looks reasonable because the hypotenuse is still the longest side, no problems. So now we need an angle. So we just need to nominate an angle. So I'm going to nominate this angle, and I'll just call it theta for now. So cos theta is equal to adjacent over hypotenuse. Now, this is the hypotenuse and this is the adjacent. Why did I choose cos when I had all three sides? The reason I chose cos is because these were the two sides that we're given. We may have made a mistake, or we may have rounded, or we may have done something calculating A. So I wouldn't use A to go and work out the angle in case there's an inaccuracy or a mistake in it. So that's why I've used cos. And cos theta is equal to 49.1 divided by 72.3. So cos theta is equal to 0.6791. And I've gone to 4 decimal places there. So that means that theta is equal to, using the cos to the minus 1 idea, so theta is equal to 47.23 degrees. So this other angle, let's call it beta. So beta is going to be 90 minus 47.23 degrees, which is going to be 42.77 degrees. So now we've completed the triangle. We've got all the sides and we've got all the angles.